Today we're going to have a refresher on trig IDs. All of these can be found in the front cover of your book. If you can't find them in the front cover of your book, go ahead and use the photocopy I made of them and post it on Haiku. You will need to know many of these for the AP exam. For now, feel free to use your book to check and see which ones would be useful, but eventually most of these need to get stuck into your head. Some really important ones are the trigonometric identities that involve Pythagorean theorem. These can be derived one from the next. The first one comes from, just to remind you where these come from, the unit circle. The coordinate of any point on the unit circle is cosine of the angle, comma, sine of the angle. And I can make a little right triangle here where sine is the vertical part, cosine is the horizontal part, the hypotenuse is the radius of the unit circle, which is 1, and that's how we get this trigonometric identity using Pythagorean theorem. The others also can be found in a unit circle and use Pythagorean theorem to do that as well. Or I could just simply take the initial equation and divide everything by cosine squared. And simplify using reciprocal definitions of trigonometric functions. So from this we would say I have tangent squared, and here I have 1, and the last term here is secant squared. Similarly, I could do the same thing, except instead of dividing by cosine squared, I could divide by sine squared, and I would end up with 1 plus cotangent squared equals cosecant squared. So if you forget where they come from, either use the unit circle to demonstrate, or to demonstrate all three, or you can use the first one from Pythagorean identity and then derive the others by using division of either cosine squared or sine squared. So these are going to come up often when we're trying to find a derivative or simplify a derivative, or if you've already taken a derivative and the answer in the back of the book or on the AP, the choices do not look like your solution. For example, if I want to take the derivative with respect to theta of the expression square root of 1 plus tan squared, this is complicated and we don't yet know how to take the derivative of a function inside a function, so I need to rewrite it in a way that I can take its derivative. 1 plus tangent squared, as we remember from the previous page, is equal to secant squared. So I really have the derivative of the square root of secant squared. And from here, square root and the squared cancel out, and I end up with the derivative of secant, which I can take, and I do know how to do, and that's secant theta tangent theta. So tonight for homework, some of the questions you have will ask you to use trigonometric IDs in a way that helps you simplify and find a derivative. Again, I have a case of a function inside a function. I have sine as my outer function, but 2x is inside my function. So I kind of have one of these cases where I have a composition of functions. We don't yet know how to take that derivative. That's our next unit. But for now, we can use trigonometric identities to rewrite sine 2x in a way that we can take its derivative. So right now, press pause and try to find a trigonometric identity that you could replace sine 2x with, and then take the derivative using the tools we already have. So hopefully you were able to rewrite sine 2x as 2 sine x cosine x. I now have a product rule, so I can use a product, so I can now use product rule. If we simplify just a little bit, oops, no more derivative. That is the derivative. We end up with negative 2 sine squared x plus 2 cosine squared x. I could simplify even further, and I don't know if your book will, but I notice that I've got a sine squared and cosine squared here. I could pull out the 2, and I have cosine squared minus sine squared, which doesn't have an identity, but cosine squared plus sine squared does, so I can replace either the sine squared or the cosine squared with something. And I end up with 2 times 2 cosine squared x minus 1. I could distribute the 2, but at this point we see that we can write this many different ways using our trig IDs. That'll be part of the goal of homework. Or no, sorry, class tomorrow. This is just like the last problem, except your trig ID that you use this time should be for cosine of 2x. So again, my suggestion is rewrite using a trig ID, and then go ahead and find the derivative. Press pause so that you can do this on your own, and then check your work. So yet another example. There are other ways that you can actually split up cosine 2x. There are other trig IDs for this. I could rewrite one of the sine squared or cosine squared in terms of the other and get a simpler trig ID for cosine 2x so that I only have to do product rule once. This is another way to rewrite cosine 2x. So you could take the derivative of this instead. It will work out to be the same. One of the things we didn't do in class last time was to talk about the limit as x approaches 0 of sine x over x. We just kind of said, oh, it's equal to 1. We also kind of ignored the limit as sine x, as x approaches 0 of cosine x minus 1 over x. We just said that equals 0. There's a squeeze theorem we can use The squeeze theorem we were using wasn't working for us, so we will discuss that in class, as well as use more trig IDs and solve problems using trig IDs to find derivatives. So I will see you in class. You have a few graded homework problems. I also assigned 2 extra problems from the book for homework, and those, I believe, were 33 and something else, but I'll double check and post it on Haiku. Hope you had a great weekend. I will see you tomorrow.